Okay, this problem says, what is the particular solution to this differential equation with the initial condition y of 2 equals 1? All right, this is multiple choice. This is a very likely thing to also show up on an open response, so it's a key idea. So if you use separation of variables, then you get dy over y squared is equal to x dx. Okay, and then we take antiderivatives of both sides. Probably nice to think of this as y to the negative 2. So that when you take its antiderivative, you add 1 to the exponent and then fix that. So that should do it. And then on the right side here, it's just 1/2 x squared plus c. We can plug in our initial condition at any time, so that kind of depends on the person. I think maybe my students, maybe make it more concrete if we do it now. So plugging in, the initial condition, so that tells us that negative 1 to the negative 1 is equal to 1/2 2 squared plus c. Okay, so the opposite of the reciprocal of 1 is just negative 1. This is 4/2, just 2. So c is equal to negative 3. Okay, and so now back here. I like to now go back to this form. So this is x squared over 2 minus 3. Now we don't want to isolate, so you can multiply through by negative 1, I guess. If you do that, notice you get this. And then you can, if you treat this as a fraction, these can just swap, right? So you get y equals 1 over 3 minus x squared over 2. So you might not find that answer because you don't see it. That probably means the answer doesn't have a fraction in the bottom, so times the top and the bottom by 2 to get this equal to 2 over 6 minus x squared. And that's D. There may be other algebra paths you took, but you should end up there.